NASA's James Webb Space Telescope, JWST, launched in December 2021, has rapidly become one of the most powerful instruments ever created, setting the stage for a new era in the search for extraterrestrial life. This cutting-edge telescope is not just taking stunning images of distant galaxies, it is peering deeper into the cosmos than ever before, with a mission to uncover some of the most profound questions humanity has ever asked. Are we alone in the universe? With billions of planets scattered across the cosmos, it seems likely that somewhere out there, life may exist. For centuries, humanity has wondered whether we are the only ones in this vast universe. Until recently, the search for alien life was the stuff of science fiction, but new advancements in space technology have moved us closer than ever to finding answers. One of the most groundbreaking tools in this quest is the James Webb Space Telescope, a state-of-the-art observatory designed to study the earliest stars and delve into the universe's past, potentially revealing alien life in ways previously unimaginable. The idea of finding extraterrestrial life is certainly not new. Early astronomers made incredible discoveries through their telescopes, unveiling the mysteries of distant stars and planets. However, it wasn't until the launch of space-based observatories like the Hubble Space Telescope that we truly began to explore the possibility of life beyond Earth. Hubble revolutionized our understanding of the universe by capturing stunning images of distant galaxies and exoplanets, planets that orbit stars outside our solar system. Yet, even though these discoveries were groundbreaking, they raised new questions. Could any of these far-off planets be capable of sustaining life? How would we ever know for sure? This is where the James Webb Space Telescope comes into play. Unlike its predecessors, JWST is equipped with advanced instruments that allow us to not only take breathtaking images of distant space but to analyze the atmospheres of exoplanets that lie light years away. By studying the light that passes through a planet's atmosphere, we can detect chemical signatures, biosignatures, that could be linked to life. These biosignatures might include oxygen, methane, and water vapor, chemical markers that could point to biological activity on distant worlds. Detecting these substances in the atmospheres of exoplanets would represent one of the first significant clues in the search for alien life. However, finding biosignatures is just the beginning. In addition to biological markers, scientists are also on the lookout for technosignatures, indicators that a technologically advanced civilization might exist elsewhere in the universe. Imagine detecting an exoplanet emitting unusual patterns of electromagnetic radiation, or artificial light sources. These signs could indicate the presence of intelligent life forms with technology similar to our own, capable of communicating across space or even shaping their environment with advanced machinery. In fact, detecting technosignatures could open up a whole new chapter in the search for extraterrestrial life, expanding the scope from microbial organisms to entire civilizations. JWST's ability to uncover technosignatures, along with the upcoming Nancy Grace Roman Space Telescope, which is set to launch in the mid-2020s, promises to significantly enhance our search for signs of alien life. Roman will be able to survey exoplanets with even greater precision, potentially helping us to detect unusual signals or signs of artificial light. This, in turn, would deepen our understanding of the possibilities for intelligent life beyond Earth. Yet, as promising as these advancements are, the search for alien life remains full of challenges. While it may sound exciting to detect oxygen or methane on a distant planet, these chemicals are also produced by non-biological processes, such as volcanic activity or chemical reactions in a planet's atmosphere. This means scientists must carefully rule out other potential explanations before jumping to conclusions about the presence of life. In fact, interpreting the data gathered by JWST is no simple task. One small molecule, like methane, could have multiple origins, and discerning the true cause of its presence will require years of work. There's also the issue of distance. Even with powerful telescopes, The vastness of space means that the signals we receive from distant exoplanets could be millions or even billions of years old. It's possible that by the time we detect these signals, the conditions on those planets may have changed entirely. We might find that the planet we're studying once harbored life but no longer does, or we could detect signs of life that no longer exist, making it even more difficult to draw conclusions about the current state of the planet. Then there's the question of what alien life might actually look like. On Earth, we base our understanding of life on carbon-based organisms that depend on water, oxygen, and a specific range of environmental conditions. But what if life on another planet is radically different? What if it thrives in environments that we'd consider hostile, on planets with toxic atmospheres, extreme temperatures, or crushing pressures? If alien life is based on a completely different chemistry, it may not leave the biosignatures we're accustomed to looking for. This forces scientists to rethink what defines life, and how we might recognize it in other forms. As we continue to develop more advanced space telescopes, including future missions like the Luvoir, Large Ultraviolet Optical Infrared Surveyor, which is still in the planning stages, the possibilities for detecting alien life continue to grow. These future missions could provide even more detailed insights into the atmospheres of exoplanets, expanding our search for both biosignatures and technosignatures in ways never before possible. Despite these technological advancements, detecting alien life, whether through biological markers or technological indicators, remains an uncertain prospect. Even with the powerful tools at our disposal, there are still many unknowns. The challenge of interpreting data is compounded by the limitations of distance, time, and the sheer complexity of alien environments. For example, detecting microbial life on Mars might be a possibility, but the traces it leaves behind might differ significantly from what we would expect based on Earth's biology. While these challenges are significant, they also offer opportunities for growth. As we continue to refine our methods of data interpretation and expand our understanding of life itself, the search for extraterrestrial life becomes more about broadening our definition of life and what it might look like. We are learning to search for life not just in the familiar forms that we know but in new and unexpected places. For example, moons like Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, have subsurface oceans beneath their icy surfaces, which might harbor microbial life. These moons, along with the upcoming Europa Clipper mission, could offer insights into the potential for life right here in our own solar system. The search for alien life is an exciting and complex journey that may still be decades away from yielding definitive answers. But with every discovery, whether it's a new exoplanet, an unexplained signal, or a breakthrough in our understanding of biology, our ability to detect alien life grows stronger. JWST and the next generation of space telescopes are pushing the boundaries of what we thought was possible, and with each new advancement, we come one step closer to answering the age-old